Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to EV Component Review, Components Review. This is the logic board from an EBMX X-9000 controller. There's a couple things I don't like and a whole bunch of things I do like. So let me get the don't like list out of the way for the most part, or all the way out, and then I'll move on to the other stuff. So, there are three things I don't like, and the first one is love and hate, and that's potting. So I like potting because, well, it keeps like components nice and stable, and keeps like wiggling and movement and stuff from happening. As you can see, that cap moves. But with potting around it, that's a total non-problem, because everything is secured so it can't move. Potting is very good for like waterproofing, so, you know, power it up, you know, it's got 82 volts across the controller, stick it in a bucket of water, nothing happens. Because water can't get to anything, it's waterproof. All of that potting is also thermally conductive, so if you do have heat, which is most likely going to be in your capacitors, which is generally bad for capacitors under any circumstances, then all that potting is going to conduct the heat away and keep the capacitors cool so that they live much longer lives. So from those perspectives, potting is very good. However, from a repair perspective, which I do quite a lot of and have been doing since the late 1970s, potting is a pain in the neck. Getting it removed from the board is problematic at best, and like the back 8000 with the rubbery silicone potting that it had, I still broke 2 parts on the board. Even though I was being massively careful, I still broke 2 parts. And if you use hard potting, which is like what EBMX uses, you're not going to break it loose. You'll use a lot of heat, and you'll probably still damage parts because the potting is really stiff. And you're probably going to have to take at it with chemicals instead to get the potting to break down. It's a much harder thing to break apart, but it's also much more stable too than the silicone rubbery stuff is like ASI uses. You know, you saw me slam the controller on my bench several times because I had no fear of harming it. So that's what potting's good for. For repair, yeah, not so much. I don't like this part either, so these solder pads here, these are actually through holes, and they're here and here as well, and those are for pin headers, which you can see on this power stage here, and they're soldered in place. I like how KO did it much better. They used actual connectors, and their connectors would float a little bit, so this board could move and thermally cycle slightly different from the power stage. You can still do that with the EBMX. You know, it's got enough flex in there to do that, but they're soldered in place, which means that getting this board off of the power stage is now significantly harder. So much so that despite my extreme care, I still managed to rip up, not completely, I took them up the rest of the way, partly ripped up these 3 pin headers right here. So they were here, here, and here. I only partially tore them up, but once you do, you just kiss your ass goodbye because you're not going to fix that problem ever again. By the way, this one and these ones were the easy ones. This one right here, that's the hard one, and that one is still intact. So go figure. I have taken up pin headers like this many, many times and not torn them up from the board. So yeah, call me a gorilla if you like. I obviously screwed up, went too hard, and didn't think I was. So yeah, I would prefer that they weren't soldered in. I'd prefer they weren't connectors. Even though this whole thing is potted, you know, that still makes my life as a repair person way easier. Alright, so that's all the things I don't like. These capacitors, they are a brand called Yimin. I've talked to a couple electrical engineers about them that use Chinese components, and they like Yimin quite a lot. So yeah, they consider them to be very good Eastern capacitors of high quality. I also asked them about the Kajing brand that's in the KO controller, and they all said never heard of him. Yeah, some way off brand version that's pretty much junk, and that's everything that I said about that before when I did my KO Pro Teardown. Anyway, yes, this Yimin brand is well liked. Aishi, which is what this one is, again, well liked, and I already knew that one was. I just didn't know this Yimin brand. So yeah, I've got actual electrical engineers that tell me these are great caps. So, okay, good enough. You guys use them for real. You design around those parts. I can accept that. So right here you have 3 current sensors, and this is standard VESC fare that you have a current sensor for each one of the phases. And this is a VESC controller, through and through it is. Yeah, and that's just part of the VESC standards that you have a current sensor for each one of the faces, and you've got 3 of them. So that's all very good. On this section of the board over here, you have an inductor, you've got the little buck chip right there, and here is the MOSFET for the thing. Yeah, that makes up a 12 volt, 5 amp DC to DC converter that you can use for lights, a horn, I don't know, whatever you want to use it for. But, you know, EBMX included it on the board. Who does that? And here it is. You know, that's cool. That's, you know, extra stuff that you don't get with anybody else's controllers. Furthermore, the little bit of electronics right up in here, and here's another MOSFET right there, that makes up a switch for turning on and off a water pump. So you can liquid cool your motor or your controller or both and do it all, ta-da, right from the controller, and use the 12 volts on board to power the pump. You know, that's totally cool. I mean, EBMX was thinking about what people want in their high power EVs, and they included that stuff on their design. Let's talk about the onboard DC to DC stuff. So that's all right here. And so you have the larger one right there that takes battery voltage down to 12 volts. This one takes takes that down to 5 volts for the 5 volts electronics on here. And then right there you have a linear regulator. That's a TMS 1117 that makes 3.3 volts to power the CPU. So KO, here's an apology from me to you. You know, I kind of smashed you guys pretty hard for that one, because you're using the same linear regulators on here. And since doing that teardown of the KO Pro, I've found the exact same linear regulator on Tronic controllers, which is a good American brand, and also on ASI, which is a great Canadian brand. So yeah, 2 brands which I have a great deal of respect for. Well, actually 3, EBMX, all are using the same linear regulator as you guys have on yours. So apologies, you know, you guys kind of deserved it because, well, you've been smashing me over the head for telling the truth about your controllers forever. And so, yeah, I kind of smashed you back on that one. The CPU here, that is a, whatever that is, a Giga Logic something or another. Yeah, I can't see the part on there. Let me look off camera so I can see that part. Yeah, Giga device, that's what it is, GD32F405. Sorry about that. So that is, you know, basically a clone of the STM32F405. It's got nearly the exact same functionality in it. The only reason why EBMX used this instead of the STM32F405 is because they couldn't get it. We've all heard of this thing, like in the news, you know, the chip shortage. That's why they used it. Not because they had any other choice. Otherwise, they would have used the STM32F405 and not this one. They simply, if they were going to make controllers, they had to use something else, and they did. And another side product of that is now there is another chip that supports VESC. Whereas before it was just the STM32F405, now this does too. And that has never existed before in time. So good job, EBMX. You used what you had to use to make controllers, and you created a whole new platform for VESC that never existed before. Thumbs up. Good job, VESC. Or good job, EBMX. All right, so this right here, this is another DC to DC converter for 5 volts. What do you need 2 of them for on the board? Because you got one here too. Well, this one right here powers all the onboard electronics. This one powers all the offboard stuff. So like hulls in your motor, throttles, an LCD display, whatever you need 5 volts for that's not on the board, that's what this does. It's all it does. So yeah, you have a 5 volt power supply that's just for onboard stuff and a 5 volt power supply just for offboard stuff. I have never seen this on a controller ever before, and I have taken apart, I don't know, 30, 40, 50 controllers over the years. Doing repairs on them, trying to upgrade them, mod, stuff like that. And I've never seen this before. So that's a cool thing. That's called attention to detail. I'm pretty much done with this side of the board, but I got to point that thing out. That's way cool. Good job, EBMX. Let's flip this thing. Okay, so I forget if I mentioned this or not, but yeah, you can see all the flux on these capacitors. So all the through-hole components that are here, they were all wave soldered. So basically you have this big vat of solder, and it makes this nice, really smooth wave, and it just goes, flows right across everything with the board like this, and it just solders everything all in a second. So it's really quick, and it's really reliable, and it makes really consistent results. So all these pins on these connectors are wave soldered. There's some smaller parts, like all the little current sensors are all soldered with the wave soldering. But something happened, and it didn't quite work right. You know, the wave got out of sync or something like that. And all these larger capacitors didn't get soldered correctly. So somebody came through, and they manually soldered them after the fact. So good job in catching a solder failure and manually fixing that problem. So that's called quality control, and that's not a bad thing. You know, that's not a problem. You know, that's a good thing. Anybody who does that, good for you. What I don't like is the fact that they didn't clean up the flux. Come on, guys, clean up the flux. Okay. Yeah. So I've already ranted on that one. All right. So you have this circular trace, and here, and here, and here is the power stage, and that's battery plus. Oops. Sorry, bumped the camera. And this is battery plus, and those touch down to those rather large and beefy standoffs. You know, they're literally 4 times larger than the ones in the KOs. Yeah, and this isn't even a current path. Yeah, unlike the KO, which that is a current path. Yeah, this is basically only here for ripple filtering. That's it. Just for the capacitors. It's not delivering current anywhere. Nowhere. And, you know, it's got this big wide piece of copper all the way across here. It's not like those 2 little skinny things with some solder reinforcing on it. That's a big wide piece of copper that does nothing but do ripple filtering and that little fiddly bit of current that's involved with that. So, yeah, this is gracious plenty for that. These 3 circular pads, they go to battery minus across those. These 2 right here, they have vias all around them, and there's several vias here and over there and there. And then there's a copper sheet inside here that basically covers the entire surface area inside the board, and mostly comes up to these capacitors. I've measured resistance, and it's very, very low from either one of these to the negative legs on any of these capacitors, or from here to here. And when I shine a bright light through it, I can't see through the board anywhere, because it's completely black from that ground plane inside there of copper. Anyway, yeah, those ones bring the ground or the battery minus plane up to these capacitors. That's pretty much all they do. And also provides a nice RF shield across everything too, which is a good thing. Then you have this one here, and you'll notice it has a cut all the way around it. Well, it's actually, you know, an etching rather, because the copper on the surface has been etched away. So this right here, and just that one battery minus connection, what is right there? All the small electronics. This creates an isolated RF shield. Imagine, if you will, putting the small electronics kind of like inside a Faraday cage or something. This produces an RF shield underneath all of those components so that they don't get RF noise from the power stage. This is called attention to detail, people. This is a good thing. The only place it connects is right there to here. That's it. Otherwise, it's a completely floating RF shield. All these little circles on here, those are vias, but that's all for the little electronics here. It doesn't have anything to do with, you know, power or anything like that, like these vias over here do, to get battery minus up to all these capacitors for ripple filtering. Yeah, no, those are just for inter-circuit transfer of signals from one small component to the other. This is really good. That whole entire via inside, or that entire plane in there, just for RF filtering. So, good design. Pretty much like everything I see here so far. Yeah, good job, EBMX.